Now let's look into the limitations of multi-dimensional scaling. Unraveling limitations of multi-dimensional scaling and feature engineering for supervised machine learning and its impact on explainability. So multi-dimensional scaling has several limitations when used in feature engineering. Process for feature engineering and process for supervised machine learning. So the first one is loss of interpretability. While MDS can reveal patterns and similarities among data points in a lower dimensional space, the interpretation of these dimensions may not always be straightforward or easily interpretable. So, especially when the number of dimensions is large. Then linearity assumption, basically non-linearity. MDS assumes that the relationship between variables are linear. If the underlying relationships are non-linear, MDS may not accurately capture the data's structure and could lead to the suboptimal feature engineering. Then we have loss of information. So MDS reduced the dimensionality of the data by projecting it onto a lower dimensional space. This projection may lead to some loss of information, making it challenging to fully explain the reduced set of features and their relationships with the target variable. Then the one more thing is scalability. The MDS can become computationally expensive for large data sets, especially when calculating the pairwise distances. For very high dimensional data, other dimensionality reduction techniques may be more efficient and suitable. And the most important limitation, so dependency on distance metric. MDS results depend on the chosen distance metric, and different metrics may produce different lower dimensional representations. Selecting an appropriate distance metric that aligns with the data's characteristics is crucial, but it can be challenging in practice. So regarding the statement, like as I always say, as a data scientist, it's multi-dimensional scaling and this kind of dimensionality reduction method. So before you use it in practice, you have to think 1,000 times. So it's essential to understand that MDS, like other dimensionality reduction techniques, is not explicitly designed for feature engineering in the context of supervised machine learning. While MDS can help visualize data and identify patterns, it's not typically used to engineer features that directly explain the target variable. So feature engineering aims to create new informative features that enhance the predictive power of the machine learning model, while MDS may help understand the data structure and the relationships. It's not necessarily can help you out in feature engineering. Even though it helps, it makes some features, the explainability is very less. So in summary, MDS can be useful exploratory tool to understand the data relationships and identify clusters or patterns in a lower dimensional space, bringing down higher dimensions into lower dimensions. However, its application in feature engineering for supervised machine learning may be limited due to non-linearity, loss of information, and challenges in interpretability. So for feature engineering, other techniques such as domain knowledge driven feature engineering or model based feature selection methods are commonly employed to create features that are more directly related to the target variable and improve the model performance. And there you will have a lot of explainability. You can explain the why the respective feature has been selected, but that's not possible with the multi-dimensional scaling.